Hello everyone and welcome to another video. So in this video we're talking about another aspect of solving equations, and this is how we would approach solving equations when brackets are involved. Now I'm going to split this up into two videos showing you two different ways we can think about this. Now I'm going to do a couple of questions for each video, but let's take a look at this first one, and I'm going to talk about how we would solve this by first expanding the brackets, which is something I talked about in my Year 7 algebra series. So you can check that out if you can't remember how to do an expansion of the brackets. Now, I talked about it long form and in depth in that video, but what we came to the conclusion of was that when we want to expand brackets, our number on the outside interacts with both of the ones on in the inside of my brackets. So it ends up, because what's implied here is a multiplication, 3 times x plus 2. So my number 3 on the outside is going to times by both my x and my 2. So to expand this, I'm going to get 3x plus 3 times x gives me 3x, and 3 times 2 gives me 6, and that gives me 18. Now, I'll go through this a little bit quicker because we've talked at length about how we solve equations systematically, but I'll approach it in the same way. So our next step here, we want to see what was done last to the x. So we times it by 3, then we added 6. So the first step in solving our equations is going to be to undo my adding of the 6 by subtracting it from both sides. This kills my 6 here, and this shows me what 3x was before I added the 6 to it. So I get that 3 times x equals 18 minus 6 gives me 12. And now from here, a lot of you, if you know your times tables, you can probably guess what x is right off the bat, but it's being multiplied here, so we can do the opposite. So x is being multiplied by 3, so we can divide by 3. Divide each side by 3 to see what x was before we multiplied it by 3. And in doing this, we get that x equals 4. Cool. Okay, so let's try another question. Now, just a quick recap. All we do in solving this equation with the brackets, it's another element that we add, but all we do is we expand first. We get our thing here into something nicer, something that we're more familiar with. Now, we're familiar with solving equations of this form, so the expanding gives us that luxury. Now, let's try another question. And I'll try a slightly trickier question. Let's do this one here and see what we come up with. We'll do just one more example here. And I'm only going to do 2 examples because a lot of these we do in the exact same way. We always look to expand first. In some cases, which I'll show you in the other video, we can do it another way. But I like doing it this way because expanding it first just gives us something nice like we got up here. And it makes the equation familiar, and we already know how to solve these systematically. So I've added another element to this question, this little 4b here. But we can see that we don't actually have to be scared of this. It actually doesn't affect us too much in our approach to the question. So, whoops. Sorry, everyone, just got closed out of my tab here. Now, my question 2, I have 3 outside of b plus 5, plus 4b gives me 29. Okay, cool. So, once again, I'm going to always look to expand this thing here because this particular expression, well, this entire equation looks kind of unfamiliar to me. I want to first expand it and then try to make it really digestible and easy to work with. So once again, when I expand my brackets, my 3 multiplies with b and by positive 5. So I'm going to get 3b, because 3 times b gives me 3b, plus 3 times 5 gives me 15. And to that, I'm adding 4b, and that gives me 29. Okay, so what I want to do here, I can see I've kind of got an equation that I'm used to, but there's this extra term which is a little bit weird here. I'm not used to this. But we can see that I have here 4b. I also have 3b here. Now, if you remember from algebra, algebra teaches us that when we have things in this form, we can add like terms. So I can group these together. I'm just going to rewrite my line, but just in a different format. I'm just going to shift this 4b over. So you can see that I have like terms here. Now, if I add 3 lots of b with 4 lots of b, I wind up with 7 lots of b. And to that, I'm adding 15. And that gives me 29. Okay, sweet. So let's consider now where I can go from here. And you should be able to see that once again, we have my equation here in that same form we're used to. We've done an extra step here, but we've made it into a nice 2-step equation that we can systematically solve. So, considering this one here, I'm going to look at what was done last to my b. You can hopefully see a pattern here, guys. Once we get to this form, it just becomes the same thing every single time. As long as we consider the last thing that was done to our equation and just do the opposite, we can always solve this equation in the same way. So here, I plus 15 to my 7b. So I want to figure out what 7b was before I added 15. And I find that by doing the opposite thing here to cancel it out. So I now get, well, what was 7b before I added 15 to it? I get that 7b equals, now what's 15 less than 29? That is 14. So once I get here, I can, once again, you can see it's kind of the same thing every time. I'm multiplying b by 7 here to get 14. So to figure out what b was before I multiplied by 7, I can divide both sides by 7. And that's going to kill this thing here. And it's going to leave me with b. And I get b equals 14 divided by 7 gives me 2. So even when we see an equation like this, even though there's one more step that looks a little bit scarier, we can always build to a nice form of the equation that we can solve systematically. And we do this by first expanding the brackets, and then we can collect like terms as well. So I've got 2 questions here in which they build up a little bit in difficulty, but we approach them in the same way. So here 3 was multiplied by x plus 2. We just expand first, then solve systematically. In this step, this question, I should say, the steps were that we expanded. Then once we got my thing in an expanded form, I noticed that there were like terms. So I can collect any like terms or any numbers as well. And I'm going to simplify this using what I know from algebra. and then I get something else in that same nice systematic form that I already know how to solve. So that's the first part of the video. I'll teach you another strategy or another way we can think about this in the next one. But thanks so much for watching, and I'll see you there.